Hi, I'm Keenan.
And I'm Byron.
And our model that we decided to look at was how we can optimize ibuprofen efficacy. So we've all heard our mothers to tell us that we should take ibuprofen with food, and we wanted to look at why that is the case. And more specifically, what type of food and the nutritional content of the food, and how does that affect ibuprofen's effectiveness in our bodies. So we decided to look at three different kind of categories or conditions on which the body is taking food. The first being a fasted condition in which no food is taken. The second being a light breakfast, which is mostly carbohydrates and very much protein. And the third was a heavy breakfast, which had a lot more protein through eggs and bacon and not as much carbohydrates.
So if you take a look at our model, we actually have two stock flows that are running in parallel. One of which is three stocks, ibuprofen disintegration throughout the body, independent of where it is in the body, milligrams of ibuprofen disintegrated in the food, and milligrams of ibuprofen disintegrated in the blood plasma. These kind of three stocks are kind of shown in these differential equations as dy1 dt, dy3 dt, and dy5 dt. An interesting thing to note about dy1 dt is it just is shown as a normal decay rate. However, once the ibuprofen tablet is disintegrated below 50% of its starting rate, which was 800 milligrams, it is more readily absorbed by the body, so you see an increase in the slope. Looking at the parallel stock flow, we have the milligrams of the ibuprofen tablet as a whole in two of the parts of the body, which is the ibuprofen in the stomach and the ibuprofen in the intestine and colon. The reason for this is that the stomach absorbs ibuprofen at a different rate than the intestine does. And when you have caloric intake that gets close to around 3,000 calories, the rate at which the food in the stomach and like the ibuprofen in the stomach get to the intestine slows down dramatically by up to like 15 hours as shown in the data set that we had.
So looking at our model in action, we first have the disintegration rate that Byron mentioned earlier, which does increase in slope as the gel the gel does of the ibuprofen tablet does disintegrate. The data we had showed this graph. They used radioactive tags to model the decrease in ibuprofen, and they also measured through blood samples of the ibuprofen in the blood concentration as a whole. Our first graph, as we've shown, models it pretty well, and our three intermediate stocks we do not have data for, and then finally our ibuprofen in the blood plasma, which we modeled as in milligrams. As you can see, the first stock, all three stocks model a double peak behavior, which is very interesting, mostly in part because of this decrease in stock. So after the gel capsule is disintegrated, it is more it increases in the blood plasma. The third stock on a heavy breakfast is interesting because the first peak is a lot lower, but then the second peak increases, it has a lot higher maximum concentration, and its duration lasts a lot longer. To validate our model, we found another data set which also showed the first peak. It's shown in green here, and it matches our model pretty well as the first data, so we can understand that for the overall, this is also blood concentration, it does show the behavior pretty well.
If we look now to the results, we find that we compared the protein and fat relative values, which is essentially how much the protein and fat gave to the total caloric intake. If you know that protein is about 9 grams of calories and fats are like 7 grams of calories, something like that, compared to the total caloric intake, and the caloric intake is sweeping from 0 to 5,000 and it's in kilojoules, not in calories. If you notice, if the caloric intake and the protein fat values are really high, you're going to have a really high maximum ibuprofen peak. If you have a really high caloric intake but not really that much protein or fat, you're going to have not super high of a ibuprofen peak level. Some limitations of our model are that if you have really high protein intake, you're supposed to kind of get this like double peak behavior. However, for our first peak, we don't quite model how small it is. It's still pretty big. That is kind of an issue with our model and something that we would like to work on in future work.
Another example of what we want to work on in future work is look at specific meals that we can plan out for someone who wants to have an optimal ibuprofen concentration, because eating 5,000 calories is kind of a lot for one meal. So we wanted to see and also look at the duration, because as you can see, the second peak hits it a lot longer. So what a good food would you have if you wanted an initial peak to be a lot higher, rather than it taking so many hours for you to get that maximum concentration.
Thank you.